this is a CAT 2017 question, and again you'll see that CAT will never test like complex concepts or like basically lengthy applications. So if you feel that the method that you are thinking in a certain geometry question is going to be too lengthy, like 3 or 4 angles, sine or cos to be figured out, etc., etc., there should definitely be a shorter way that you would be missing out. CAT will never test like complex things or like lengthy stuff basically. CAT will test the basic fundamentals and the like whatever we have discussed, right? So some application of that. So as you can see, right, this is a CAT 2017 question, and we'll try to do this, and we'll see that like basically how much complex this is. And this is not like that much old, this is 2017 only. So it's a right isosceles triangle, which is ABAC. Okay, I can mark arbitrary actually. Right isosceles triangle. So this is equal to this. Distance from ABAC. Okay, a point P is marked. AB, BC, and AC. It's equidistant from the three sides. Distance from this is equal. So by definition, what is P then? P is, even if it's not writing in the question, P is the in center, because it's equidistant from the side will be distance. This is equal to, so PM, PN, PQ is equal as given, and this distance is given as 4 into root 2 minus 1. So this is the in radius. So the first thing from this question that you need to, even before like putting pen to paper, you need to figure out is that the distance from the three sides is equal. Okay, the point is in center, and the distance that is given is the in radius. That is the first conclusion that you need to draw even before starting out the question. Now, okay, I have the in radius. Again, please do not get confused. Only for an equilateral triangle, if there is any point P, then this distance plus this distance plus this distance would be equal to the height. Here it's a right angle isosceles triangle. Right, so I know that the in radius, so the first thing, okay, was sort of striking the fact that this would be the in center and this would be the in radius. Now I know that the in radius in a right triangle is basically P plus B minus H by 2, right? The sum of the legs minus H by 2, as we had seen over there as well, right? Here, since it's an isosceles triangle, so the P and the B are equal, basically, right? This is equal to this. So if I denote like, okay, this is in our typical notation of opposite to C is C, opposite to A is A, and opposite to B is B. So this is basically then A, this is basically A plus C minus B by 2, which is 4 square root 2 minus 1. But here A is equal to C. And since it's a right angle isosceles triangle, what else can we figure out? Isosceles triangles mean this will be 45 degrees. So it will be a 1:1:2 root 2 kind of a setup. So if this is C, then this would be C root 2. So this is 45 degrees, right? So 1:1:2 root 2 sort of a setup. So A will be equal to, so it will be like C plus C minus C root 2 by 2. Again, let me just repeat. Isosceles triangle, so A and C the legs would be equal, and since this is isosceles, so this will be 45 degrees. So it will be like 1:1:2 root 2. Root 2 using the sign of 45, or basically using Pythagoras. So this is the 4 square root 2 minus 1. So if I carry 2 here, so it will be 8 square root 2 minus 1. And so this is 8 square root 2 minus 1 equal to, take C common. So this will be 2 minus root 2. So C would be 8 root 2 minus 1 upon 2 minus root 2. This looks a bit untidy, so we can obviously simplify this a bit further. Root 2 minus 1, if you take root 2 common here, you will get root 2 minus 1 inside as well. These two get cancelled out. 8 by root 2 is nothing but 4 root 2. So I know that this side is 4 root 2. Now this side is 4 root 2. This is an isosceles triangle. This will also be 4 root 2. So the area is half into 4 root 2 square, half into 32, which is 16 units, square units actually. This is the area. Done. Again, just the only thing to figure out was that this is the in radius, and just to basically link it to the expression for in radius that we know for a right triangle. This is for a right triangle only.
Sir.
Yeah.
Can you explain how P is in radius of this isosceles triangle?
So isosceles is given, right? And the in radius, even if it was not an isosceles triangle, by the definition, when it says that its distances from AB, AC, and BC is equal, so any point which has an equal distance from the three sides will be an in center. and obviously this distance then will be the in radius. So the distance equal being should tell you that it's an in center, and that distance itself would be an in radius. So this would be small r, small r, small r, and each would be equal to 4 into square root 2. This is the definition of an in center as we discussed. And then it's just linking that, okay, this in radius is, we know this distance is the in radius, fine. And then the p plus b minus h by 2 that we have studied for a right triangle. So sum of the legs minus the hypotenuse by 2. And again, using this in isosceles, so the legs would be equal as like you would expect as a triangle. Okay, hopefully it is clear. Again, a CAT 2019 question, even more recent than the last one. ABC right triangle, altitude AP on hypotenuse BC. Okay, this figure is already drawn, so it's a right triangle and ABC. Altitude AP on hypotenuse BC. Again, this setup that we discussed, right? That if it's a right triangle and there's an altitude, like a right triangle, and you shooting a 90-degree from a 90-degree, shooting the 90-degree altitude from the vertex of the 90-degree. This is AP. So we had seen this result that AP square was actually no, BP square. Actually, the figure is not named correctly as per the question. ABC is right triangle with altitude AP. So actually, this should be A. This should be B and this should be C. Yeah. So we had seen that for a right triangle where again the 90-degree shoots the altitude to the side in the front. So AP square was equal to BP into PC. This we have seen. If BC equal to 20, so this entire thing is equal to 20 actually. And we know this. Now, anytime that we have to find the maximum or the minimum of something, there are a couple of things that should definitely come to mind. The first and the foremost of those things should be AMGM, arithmetic mean, geometric mean, saying that AM should be greater than or equal to GM. So if we apply the AMGM here, basically, right? So basically BP plus PC by 2 should be greater than equal to the geometric mean, which is BP into PC. BP plus PC I know is 20, so this will be 10. BP into PC is AP square, so the root will be AP. So AP should be less than equal to 10, so AP max is 10. That's it. Over. So just a simple result that when you're drawing a perpendicular from the 90-degree, and this holds true in any right, like in any basically case of perpendicular from a 90-degree. So this and this, PR square will be equal to QR into RS. Product of the segments. Basically. So here the segments are, as you can see, BP into PC and AP square. So it's an AMGM thing because, and how did I strike on the AMGM thing? Because I saw the word maximum. So this sort of gave me that inequality. So it took me like, what if you like in an exam scenario, this would like again take 30 seconds to do this if you know this result. If you don't know and you have to derive, then yes, then it sort of starts taking time then. Okay.
So in short, we can conclude that maximum length of AP is equal to hypotenuse by 2, right?
In this case, yes. Like when you're dropping the perpendicular, yes. Yeah. Triangle ABC, circle BC with diameter BC is drawn. And again, the purpose of this question is to show you that what level of sort of conceptual clarity or, you know, fundamental base CAT is expecting you to have. All of you must be knowing the concepts, obviously, but like in general, this is the way to sort of apply it in an exam type of a scenario or in a mock setup. In a triangle ABC, a circle with BC diameter BC is drawn, intersecting ABAC is the length of this and this. What is the length of BQ? CAT 2080. First things first, circle with diameter in a triangle. There's a first triangle ABC. First of all, let's just keep drawing it as we read the question. Circle with BC diameter is drawn. Okay, let's draw a circle with diameter BC intersecting AB and AC at points P and Q. So that it will intersect AB somewhere and BC somewhere. And this is BC the diameter. This is important. Right. So if the length of AB, AC, CP, so AB is given as 30. Okay. AC is given as 25. CP is given as 20. And okay, P and Q, let's just label CP is given as 20. What is the length of BQ? So just to be asking in BQ. So first of all, let's understand that what all things we can apply. Like even before sort of again putting pen to paper, we know that there's a diameter BC, right? Now, what does the diameter? Two things it should immediately tell us. That okay, like obviously half of this would be radius, so you can figure out, like let's say if you join this point to P, then this would be the radius, and etc. etc. We can do that. The second thing they should tell you that the angle subtended by the diameter on the circumference is 90 degrees. So you should immediately start marking like whatever angles are available 90 here. So for this will be 90 because this is subtended by the diameter. This will be 90. Both of these are 90 degrees. I know this, I know this, I know this. Whenever, and this is a sort of a mini principle in any scenario where you face this. If there are like more than one perpendiculars, right? A good idea is always to equate the areas, right? Basically, because perpendiculars directly give the area, right? Half base height, half base height. So if I have like this height and this height, so their bases can be found out, right? So, and this would be useful in any circumstance where you have like more than one, or like these are altitudes, right? Perpendiculars. So equating areas should usually work. So if I talk about the triangle ABC, like the whole triangle ABC, the area would be half into AB into PC, because this is the height. Why is this the height? Because this is 90 degrees. Why is this 90 degrees? Because this is the diameter. Will be equal to half into AC into BQ. AB I know is 30 into PC. PC is 20 equal to AC. AC is what? 25 into BQ I need to find out. So BQ is simple, 1320 is 600 over 25 is 24 units. Over. Again, not a complex question really. But yeah, the thing, so the two tricky parts in this question was like first, basically, that is why if you see in the previous questions, there was a diagram. But here there isn't a diagram. So first converting this into a diagram is the first part. And second, just realizing that angle in a semicircle is 90 degrees. And that's it. Very, very, very short and direct question otherwise. So it shouldn't take time. So that is there. Now this question, again, any questions, or if you guys would like a 5 to 10 minute break, do let me know. Like just interject me at any point that okay, like fatigue is starting to set in or something, and we can stop at that point. And again, the coverage, like all the questions that are in this list, and these questions have been like carefully handpicked as well. So all these questions would be covered. It's not necessary that the work, like if we need to do the workshop beyond tomorrow as well, we will do it and we will cover everything. Now this is okay. KVNs are lines, basically like random lines inside a triangle. Now this may not be a median, may not be an altitude, may not be a perpendicular bisector, angle bisector, anything. Just a random line drawn from a vertex to a side is called a KVN. So all these medians, perpendicular bisectors, altitudes, angle bisectors, all these things are special cases of KVNs. Right. Okay. KVN AD is drawn to BC in a triangle ABC with AB 18. BC, okay, sides are given. Again, it seems like a lot of things are given, so should not be that tough, but let's see how to deal with this. AB 18, BC 36, AC 30, BD, okay, KVN AD is drawn, so BD is 11. BD is 11, so I can automatically figure out this will be 25. Now I need to find out AD length. Now again, this is a very deceptively simple question because again, it seems that, okay, I know, like even for the smaller triangles, I know some of the sides. So like 11 is given, so I found out 25, fine. I need to find out AD. So maybe I can apply some cosine rule here, then equate it to something else and get that. Now there is a process for that. Now that will be lengthy. Because see, if you just start like, so sort of again, if you just see these values and start off doing the questions, right, you will get stuck, and that is why they have given that question. They want you to get stuck in a like loop of like applying equations after equations. That will give you the answer for sure, but it will take you time, right? So whenever such question comes, right, wherein like these sides are given and you know a certain side inside is asked, just write those values down once. Like from the diagram directly, right? 11, 25, 36. These are the numbers, right? So again, the long method should be avoided. The point being, now cosine and sine rule are very, very useful, but in this case, if you see that they may not, like, if they will not be able to give you something directly. Why? Because we don't know all the sides of any triangle here, or we don't know any angle. So you'll have to find the cos of every angle and then basically equate it to get the answer, which takes time. If I just see the sides like 18, 30, 11, 25, 36, these are just the numbers from here. Now, if you observe something, right, 18, 30, 25, 36, right, if you observe something that this basically this 30 and this 25, there is a ratio of 5:6. Similarly, between 30 and 36, there's a ratio of 5:6. I'll explain this question from the starting as well. But just follow along that basically what I'm doing is I'm writing the sides and I'm sort of looking, just observing the ratios into which these sides are built. 25:36 gives me 5:6. It is like visible. Sorry, not 25:30 gives me 5:6, and 30:36 gives me 5:6 as well. So in a way, I can say that DC, like, or CD by AC is equal to AC by BC. This by this is equal to this by this, equal to 5/6. This is again just from observation that the sides are, once I figured out that this was 25, which is 36 minus 11, I observed that this is 5:6 and this is 5:6. So maybe I can construct two triangles wherein sides are proportional. Right. So if I talk about this triangle, the small, like, because like the sides are part of this triangle, so ADC, I know that, okay, the numbers that I'm involving are 25, 36, and 30. So which means this triangle is getting involved and this big triangle is getting involved. This triangle is getting involved because 25 and 30, and this big triangle is getting involved because of 36 and 30. So ADC can be similar to, now first triangle I can write any way I want. The second triangle, the naming is very, very key. So CD has to be matching with AC. So the last two alphabets should be AC. And AC has to be matching with BC. So the first and the third alphabets have to be BC. So the third alphabet will be C, this will be A, and this will be B. Again, let me just repeat. ADC I just wrote. Now I know that CD by AC is AC by BC. So AC, so basically CD is the last two alphabets here, so these should match AC. In what order, we don't know yet. To figure out the order, we need to look at the other equation. So AC by BC. So the first and the third should be the first and the third here. So C should both be in the second and third place, and the first and the third place. So which means C should be in the third place. And you can always check, right? So if this equation, so CD by AC gives you first and a third, AC by BC. Naming a triangle is extremely critical in similar triangles. And obviously, like, both these triangles have a common angle C, which is the included angle. So basically, this and this side we're using for proportionality, and this is the included angle, right? So that is why angle C is common. So basically, you can say that by SAS similarity, these triangles are similar. Any doubt? Again, why is this the included angle? Because these and these sides were getting involved in the similarity proportionality, and this is the included angle, which is common for this small triangle and the big overall triangle. Now, once this you have figured out, then it is extremely simple. AD by AB will be equal to, let's say, AC by BC. AD by AB is AC by BC. So AD by AB is what? AC is what? 30 by BC is what? No, AD by AB is 18 actually. Is what? 36. So AD will be 2 times and 15. Tricky question, but a very good question to sort of exhibit that, if, like, you should not, like, just jump onto the sort of writing down like equations after equations. Sine cosine rules are very useful, like very applicable, but when you have like sides and angles given in a certain way, or like the equations are clearer, Like basically, if you had something like this angle was given or any angles were given, then it makes sense to sort of use that, because otherwise you'll have to make variables and it gets very muddy thereon. So this is just basically that observing the sides and observing that in combination, basically these sides are proportional. 25 and 30 at the same proportion as 30 and 36. So very good question to exhibit that similarity is not directly given, but you can establish similarity using proportionality. This is one of the more tricky questions that we have for the set, but it's so useful to demonstrate that how, like, once you are able to establish similarity, how simple the question gets. Trivians or trivians maybe, BD and C in a triangle ABC intersect at point F such that area DFC is 5, area BFC is 10, area EFB is 8, and find the area of quadrilateral AFD. And please guys, if you feel that I'm going fast or something, please let me know. We'll adjust accordingly. Now, first of all, this question, even like before making the diagram, this question is all about areas, right? There's nothing given in terms of sides, angles, like anything basically. Just areas are given. So, okay. Intersect at a point F, area DSC is 5, area BSC is 10, EFB is 8, AEFT. So this quadrilateral area has to be figured out, right? So what, okay, so basically before we start the problem, right, in terms of area, what are the things that we know? We know to calculate areas by like 6 or 7 different ways, right? But in all of those ways, something was given in terms of length. Either side length was given, one angle was given, maybe the radius was given, circumradius was given, something was given basically, right? And we use that to calculate the area. Here nothing is given. Here just areas directly are given, right? And you need to, and again, it's not at one glance you can figure out that it's not feasible to make equations for every triangle. Okay, like half base height is, you will have like 20 variables and you will get stuck. It's not actually get stuck, it is not even possible to solve this that way, because there'll be like too many variables. For every triangle there'll be a separate base and a separate height. So it should be clearly visible that that is not the way to go. So what can be done? Like find the area of the quadrilateral. Now directly, obviously, area of quadrilateral is difficult to find. Let's just draw a line here. Call this X and call this Y. Now what property of area do we know? We had studied something called the base area ratio, right? That the ratio of the base will be the ratio of the areas of the triangles. Again, just to sort of put it in perspective in terms of a small division. So if this was, let's say, M is to N, the area of this triangle will be M is to N, right? So can we use that here? Because we don't know anything apart from areas, right? So we can only use like area based ratios. So that should be the first thing. And secondly, again, like figuring out sides and all, as we just mentioned, is easy. So now if we see this triangle, right, X and Y, now observe this line AB carefully, this line AB. So along AB, right, if we, now AE by EB will be equal to X by 8 by the base area ratio. X by 8 is AE by EB. Also AE by EB, if you see the bigger triangle, like the whole triangle, then AE by EB is this entire area by this entire area. So basically X plus Y by 5 over 18. So whatever lying in this part and whatever lying in this part, the ratio of that. For the smaller triangle, this was X by 8. Like for AFB triangle, it was X by 8. So I know that X by 8, because they lie on the same base, so X by 8 is equal to X plus Y plus 5 by 18. To basically give us one relation at least, which is 10x will be equal to 8y plus 40. Yeah. So this is one. Now can I get another equation like this? If I am able to get another equation, then this is done then, right? Now let's see. Now I know 8, 10 and 5. So I can see that if I make an equation, let's say along this line across BD, so here I'll have 10 by 5, which is 2. So I'll have like one thing as a given. So along BD, if I see, so in this triangle, in BDC, BF by FD equal to 10 by 5 equal to 2. Also BF by FD in this triangle, in the triangle on the other side, is equal to 8 plus X by Y. 8 plus X like corresponding to this part and Y corresponding to this part. So basically 8 plus X equal to 2Y. X equal to 2Y minus 8. You put this here. So 10 into 2Y minus 8 will be 20Y minus 80 is equal to 8Y plus 40. Y equal to 10. 120 by 12, that is. X will be equal to 2Y minus 8, which is 12. So X plus Y will be equal to 12 plus 10, 22 is the answer. Again, a very good question, like exhibiting the base area ratio concept here. And this actually, now that you've seen this question, now you'll not forget this like ever, basically. Like wherever these segment areas are given sort of, and you're asked an area of a different segment in a triangular setup, base area ratio will always come to the rescue. Right. And there is like again, like there are concepts around mass point geometry, etc. that will also help us to figure this out. But again, no need to get into this. Just remember that the ratio of area will be the same as ratio of base, like in sort of adjoining triangles. So now, whenever you see this figure, you will be immediately reminded of this. This actually, a variant of this question came in CAT 2019, if I'm not wrong, or 18 probably. Any doubts on this question?
Yeah, sir. How much long we can do this class?
Yeah, maybe this will be the last question now, like the next one.
Okay.
Okay, and then we can probably call it a day, and then we can continue tomorrow. Right.
Okay.
They're around actually like around 22-ish questions probably total in terms of like actually around 20 of them are from triangles and the next 2 to 3 were from polygons, but since we can't cover them today, we'll definitely continue from this point on tomorrow. And tomorrow actually we can start early if you feel like that's helpful, let's say from I don't know, maybe 7 p.m. or something, and then go until 10:30, 11.
Yeah, that would be fine.
Yeah, okay, so we can start early, no problems there. A variant of this question came in CAT directly, and it's again a very direct result there. But let's derive it so that again, mugging up shouldn't be the approach, really, right? Medians AD and B of a triangle ABC are 15 centimeters and 8 centimeters respectively, intersect at 30 degrees. Find area of the triangle. This template question you will find in many places, even in mocks. Like two medians will be given, the length will be given, they're intersecting. Either they're perpendicular, in which case this 30 will be 90, and etc. etc. So it's just good to have a certain standard approach in mind, right? Now, this is a triangle. And let's just forget this question. Let's just basically get the result itself and derive it. This is theta basically. Again, for this question is 30 degrees, but we're trying to derive this more generally. Medians means midpoints. Okay, this does not look like a midpoint, but assume for now it's a midpoint. And so this is the midpoint of this side, this is the midpoint of this side. Okay, that much we know. This is where the medians are intersecting, so this will be the centroid, that much we know. And we know that the centroid divides the median into a 2:1 ratio. So if we look at this triangle, let's for conversation's sake make the third median as well. It will pass through the centroid and it will be something around this. Like this is, let's just complete the figure with the third median as well. So this will be it. So we know two things, right? So first of all, the centroid divides any median into 2:1. 2 being the like the side, like the origin of the median, basically the vertex side. And second, we know that if all the three medians are drawn, then every triangle is 1/6 the entire area. So if I can find the area of one triangle, I can multiply it with 6 into area of one triangle to get the total area. Okay. So now if we just see this small triangle AGN, area would be equal to half into AG into GN sine theta, using the area of triangle state concept. AG, now it is 2:1, right? So half into AG will be 2/3 of AM. AM is the median, which is given like the midpoint to the median. GN is this much. This is 1/3 of the median. Why 1/3? Because 2:1, but 2 is this part. 2 is the part facing the vertex. So 1/3 into GN into BN. If BN is the total median, sine theta. So this basically gives me 1/9 into product of medians. AM is the median, BN is the median. So I've written this expression in terms of medians. So product of medians into sine theta. This is the area of one small triangle. As we have discussed multiple times, that 6 into this will give you the total area. So 6 into this will be 6 into 6, 1/9, so which is 2/3 into product of medians into sine theta. This is the standard result that you can directly apply. So here the medians were 15 and 8, theta is 30. Area of the entire triangle will be half, their total is 2/3 into product of medians 15 into 8 is 120 into sine 30, which is half, 40 over. The CAT question was like it gave that the medians are like probably it was 9 and 12 if I'm not wrong, and the intersected they mentioned that the medians were perpendicular. So perpendicular medians means this will be 90 degrees, and they had asked the area directly. So people who would have like seen this problem or like known this result, because it's a fairly standard one, would have directly applied 2/3 into 9 into sine 90 is 1. So 2/3 into 9 into 12 is basically 72 would be the answer in that case for the CAT problem. Again, it seems the length for 9 and 12, but yeah, like basically, yeah, this is the concept. So once you know this, nothing doing, you can just directly apply this. Again, the purpose is not to like cram these things up, but once you sort of do a question on this, right, then it becomes much easier to sort of recall at that point that, okay, I've seen something like this earlier. And that is why sort of I put these questions in this list, so that it becomes easier to strike those concepts in the exam scenario. So that you can easily figure out that, okay, this is similar to something that's already studied. So again, obviously it's getting a bit late now. So let's stop here for the day, but just to sort of, I'll just like flash through the slides quickly. So in case any questions that you would have, let's say, have right now, and I'm happy to take them up. This was general area ratios, which could be just solved really quickly.
Yeah, sir.
Yeah, please go ahead.
In the last question, the product of median refers to the product of any two medians, right?
Yes, any two medians, and the angle also has to be between those two medians only.
Okay. The angle will be the larger one or the lower one?
Okay, first of all, it won't matter, right? Because sine theta is sine 180 minus theta.
Oh, okay. Yes.
Yeah. So this was again the sort of the oral question in terms of, okay, you can just write these areas directly by 4 into 2 upon 9 into 5, etc., so on and so forth. This was the in-center circumcenter. You know the distance, you figure out R and R. Again, the only tricky part was figuring out that the triangle to go ahead with this and not the other one because of the obtuse condition. This is a fairly standard direct, like it's an algebra question more than a geometry question, but yeah, it is helpful to know this. This is again a good application of the fact that similarity is the ratio of heights. We didn't know any side or anything for that square, and we were still able to figure out because the ratio of side was same as ratio of heights. This is again completely, this is a CAT question dependent on the fact that the distance, the it is equal from a single point to the sides, then that point is the in center, radius is the in radius, and it was given, then it's a right triangle, so the perpendicular plus base minus hypotenuse by 2 result directly just sort of ended the problem then and there. Maximum length is AMGM. This result of from a 90-degree vertex to the perpendicular, if you draw, this result is fairly important. And then this was very simple, like just equating areas basically. This was a tricky question because it is hard to strike the similarity proportionality, but once you do this, again it ends there. But yeah, the only thing was just the like observing the sides and observing that similarity exists. This is base area ratio, great question to sort of exhibit that concept. This is a standard result which we just derived, and now that you know the derivation also, so it you'll not forget how to apply this now. It should be okay. So yeah, so again, at least the concepts till now, like you should be able to like figure out within questions that okay, where can I apply what, and we'll do some more questions come tomorrow, and we'll also cover like polygons, and then obviously we'll move across the rest of the geometry like circles and coordinate, etc. Yeah. Okay guys, hopefully it was a helpful session. Hopefully you learned something new from this. We'll connect tomorrow, potentially earlier than today.
So you will tell the time on the group?
Yeah, we'll notify like what okay, now that most of the people are here, right, like what time works convenient for you? Like obviously completely understand that like people would have Sunday plans with family, friends, etc. But like what time works convenient? Like would like
So
7 p.m. be a
I
convenient time to
think
start?
the same time would be convenient because it was earlier known, so planned everything according to this time. That's why. So
Okay, so fine, so cool. So actually 8 to 11, then we can keep it if that works, right? 8 to 11, 11:30 or
that's not
something.
issue. Yes. This time to 11, if it extended, it's okay. But if
The
it
start
starts
time.
earlier,
Yeah.
early and all, it will be problem. That's it.
Okay, no problem. So, but then, yeah, tomorrow, then let's sort of gear up for a longer session, right? And we'll again continue some more good level questions and some good applications of the concept that we've learned. But thanks a lot, guys, for bearing with me here, and appreciate you going through this with me.